This animation details the clinical implications of benzalkonium chloride, also known as BAK. BAK is a cationic surfactant which consists of a benzene ring, a substituted ammonium ion, and a 14-carbon side chain. The last two components form a hydrophobic domain, which gives BAK its detergent-like properties. These hydrophobic domains allow the BAK molecules to form micelles. An individual molecule of BAK is approximately 340 daltons in size. The concentration of BAK ranges from 0.004% to 0.02% in frequently prescribed IOP-lowering medications. Upon distillation of a drop onto the eye, the detergent properties of BAK, due to the hydrophobic domain, disrupt the tear film by dispersing the lipid layer that prevents evaporation. BAK moves through the tear film and reaches the ocular surface and begins affecting the epithelial cells with their microvilli and the goblet cells which produce mucin. These two components help anchor the tear film to the ocular surface. A closer view of the interaction of a single molecule of BAK with the cell membrane is shown. Due to the small size of BAK and the hydrophobic domain of its carbon tail, it easily enters the membrane and begins to lead to a disorganization of the individual lipids in the membrane. Other BAK molecules pass through the membrane and begin affecting intracellular processes. With time, the accumulation of BAK within the cell and the lipid disorganization within the membrane leads to holes in the membrane, leaking of cell cytoplasm, and eventually cell death. As the cells begin to collapse, they release the BAK that had accumulated within them, which impacts neighboring cells, and the cascade of BAK's toxic effects begins again. This recirculation of BAK is why BAK can be found in the epithelial cell layer as late as 7 days after a single drop of 0.01% BAK is applied to the eye. With chronic exposure to BAK, the ocular surface develops a subclinical inflammation which can lead to ocular surface disease over time. Signs and symptoms of the disease develop over the course of years. This gradual accumulation of ocular surface damage and worsening of symptoms may lead to decreased quality of life, a decrease in therapeutic compliance, and subsequent ocular comorbidities. The ocular surface damage caused by chronic exposure to BAK can be reversed by removing the daily exposure to this preservative.